Hello and welcome to the lesson today on ionic equations. Let's go. So firstly, with any kind of ionic equation, you need to recognise that you are working with ionic compounds. You should know what that means, metal and a non-metal, pluses and minuses, and that's going to be important here. It could occur in many areas of the exam or of the curriculum, but in particular it tends to appear in displacement reactions, in redox reactions, so reduction oxidation reactions, often talked about when we talk about neutralization reactions, and in electrolysis. So the first thing we need to recognise then is in order for an ionic compound to do anything to react, you've got to separate those ions, and therefore you are looking for an aqueous solution. So in this example here, you are given the states of matter and you are looking at this one here, and this one here because they are aqueous, and you would ignore the AgCl because it is a solid. So before we go any further, let's practice separating these ionic compounds into their ions. So let's look at a common one, salt, NaCl. What are the ions that actually make up that compound? So it's a bit like doing reverse ionic formulae. So NaCl is made up of Na plus or plus 1, doesn't matter how you write it, and Cl minus or minus 1 or 1 minus, it doesn't matter how you write it. How do I know that? Well, I would look at a periodic table. Sodium is group 1, so it's plus 1, and chlorine is group 7, so it's minus 1. Okay, what about this one? MgOH2. How would you separate those into their ions? This one's a little bit harder. Hopefully you would get Mg plus 2. Did you know OH is minus? You should do them talk about neutralization. It's always OH minus. So where have I put that 2? Well, the brackets around it in the compound say I've got 2 lots of the OH minus, and so I've put that at the front there to show I've got 2 lots of the OH minus. And you should recognise then that that's actually balanced. The Mg2 plus is balanced by the 2 lots of hydroxide minus. Okay, what about this one here? So hopefully you're starting to play along a little bit now. You should recognise I've got 2 lots of H plus, and I've got 1 lot of the sulfate, which is minus 2. Now I could have worked that out from the formula. I've got 2 lots of hydrogen. I know hydrogen is 1 plus, and so SO4 must be 2 minus in order to balance that out. However, you would be expected to know that ion, the charge on the sulfate is minus 2. It's really important that you're familiar with that. There's a few that you need to know, sulfate being one of them. Okay, so it's SO4, just remembering that it's polyatomic and it stays together, the SO4. That's why I've done it here, to remind you. Okay, this one here, so potassium nitrate, what would that break down into? Well, hopefully you would get the K plus or plus 1 from group 1, and recognising that NO3 is polyatomic, it's a nitrate, it stays together, and it would have a charge of minus 1. Again, if you didn't know that, you could have figured it out from the formula because you've got 1 potassium, which is plus 1, so the nitrate must be minus 1 in order for that to balance. Again, you would be expected to know it though, so you would need to know that the hydroxide is OH minus, the sulfate is SO4 2 minus, and the nitrate is NO3 minus 1. Okay, so in an ionic equation, we're only going to be working with the active ions, so we can ignore the spectator ions. Now, that might be a very confusing sentence right now. Let's work through this example and hopefully you'll understand what that means. Okay, so I am going to try create an ionic equation from this balanced equation here. So the first thing I need to make sure before you move any further is that this equation is actually balanced. Okay, now I'm telling you it is, but you would need to check that, otherwise things are not going to work out properly. So second of all, I need to identify the aqueous solutions that I'm going to be working with. So I'm going to be working with this one here, so the HCl. I'm going to be working with the NaOH, and I'm going to be working with the NaCl because they are all aqueous. And for now, I can ignore the H2O because it's a liquid. So the third thing I'm going to do then is to separate the ions. So for the HCl, I've got a H plus and a Cl minus. Again, I would know that from the periodic table, or I would just know that. For the NaOH, I would recognise I've got Na plus and OH minus. And for the NaCl, I've got an Na plus and a Cl minus. Okay, so hopefully that's all making sense so far. Now, what about ignoring these spectator ions? Well, spectator ions are not actively involved in the equation, so we can ignore them when we are looking at ionic equations. You don't ignore them at any other time, but for an ionic equation, we can ignore them. So anything that appears on both sides of the equation is considered a spectator ion. So if I look at both sides of the equation, I've got a chlorine there that I can get rid of. They're on both sides of the equation, so I can ignore them. And I've got sodium on both sides, so I can ignore them. So I've cancelled the spectator ions. Well, what have I got left? I've got the H plus, I've got the OH minus, and of course I've got the H2O that I left out earlier. And so my ionic equation is simply H plus aqueous plus OH minus aqueous, making H2O liquid. Now, first of all, notice I've left the state symbols in. That's important. And also notice, please, that that is a balanced equation. The ionic equation at 2 H's and an O on both sides. And that's how it's done. Okay, it's your turn. Pause the video, have a go. Really important you have a go at this by yourself. And as we go through it at the end, you can see where you've gone right and where you've gone wrong. It's really important to pick up where you're making mistakes or not, as the case may be. Have a go. Okay, so I'm going to follow that pattern again. I am going to check it's balanced, which it is. I'm going to identify the aqueous solutions, which is that one, and that one. I'm going to separate my ions. So here I've got Ag plus and NO3 minus. Again, I would know that the A is Ag plus 1 simply because I should know that NO3 is 1 minus, and to get that balanced equation it must be Ag plus. Often they'll give you it in the exam situation, but that's what it looks like. NaCl is that one, and NaO3 is that one. And again, if I wasn't sure about that original NO3 minus 1, I would hopefully recognise that sodium is going to be plus 1 because it's on the periodic table. I can look at that, and to make NaO3 balance, NO3 must be a minus 1. So that's how we're getting there. Okay, next I'm going to cancel the spectator ions. So that's that one there. So that's the nitrate's gone and the sodium's gone. And what have I got left? Well, I've got Ag, which is silver, and I've got chlorine. I'm going to bring those down, and I'm going to bring in this one here, which I haven't forgotten about. I was just leaving until the end, and that should now balance. So I've got 1 silver and 1 silver both sides, and 1 chlorine both sides. So perfect. I've left in my state symbols, and the job's a good one. Okay, so we're going to look at some exam questions. As always with OCR, the application of the ideas is what they're looking for, especially at this higher level. So the first question here, I just wanted to show you, there's a lot of information there. Obviously, it led on to further questioning, but the question here we're interested in is this bottom bit here. Write the balanced equation, ionic equation for neutralization. Now, it doesn't give you information where you can write out that long complex thing that we've been looking at so far, because you would be expected to know this by heart. The balanced ionic equation for neutralization is this, and it's always this, okay? Because acids always contain the hydrogen, alkalis always contain the hydroxide, and therefore they always make the water. So the other parts of the acids and alkalis, whatever they are the spectator ions. This is the ionic equation. You would be expected to know this. Okay, so this one again, pause if you want to have a go yourself. It looks a bit different. It's definitely not going to be the long version. It says magnesium ions react with chloride ions to form magnesium chloride. What is the correct ionic equation for this reaction? And it's multiple choice. You're given 4 options. For me, the best thing to do at this point is to ignore all those answers and to figure it out for myself, and then see what matches the answers. And that way, for me, it means I'm not getting confused. So I'm going to look at the periodic table because I need to know what charges my magnesium and chlorine would have. So first of all, I'm looking at the magnesium, which is here. So magnesium is 2+, okay. And then I'm looking for chloride ions. So I'm looking for that charge again. So chlorine is here, so that's going to be a 1-. Now straight away I can see that they're not balanced. I'm going to need 2 chlorines to balance out that 1 magnesium. And that is going to give me an ionic formula of MgCl2. Okay, so then I can go back and look at my options there, and I can see that the one that matches that is C, isn't it? Mg2 plus 2 chlorine minus gives you MgCl2, yeah. And so my answer is going to be C. And I find that much easier to do because I'm not getting confused and bamboozled by what looks like some very complicated answers. Okay, so this one here, it says, which ionic equation is balanced correctly? Well, I've got no other option than to go through each of these individually and just make sure I'm happy with an answer. It's asking me, do the reactants into the products make sense? Do they balance? Okay, well, at first one, I've got 2 lots of silver, so that's going to be 2+, and I've got 1 lot of CO3, which is a 2- charge. So a 2-to-1 ratio would work. So actually A looks pretty good right now. Okay, now I could leave it, but that would be silly. I'm going to double check everything, make sure I haven't got 2 correct answers. Okay, so B, I've got aluminium 3+, and then I've got, oh, hang on, I've got aluminium 3+, and I've got 3 lots of OH, which would be 3-. So that should work. But the product is wrong because it should look something like that, because the product looks like I've only got 1 oxygen and 3 hydrogen. So that's actually wrong. Okay. C, 2 lots of, so 1 barium 2+, 1 sulfate 2-. That actually works. What's wrong with that equation there? Right, well, they've doubled it up for some bizarre reason. So it balances, but it's not accurate, is it? Okay, next one then, I've got 2 lots of lead with 2+, so that's 4 pluses, and I've only got 1 nitrate, so that's not right. It should be 2 lots of lead and 4 lots of the nitrate, so that's actually wrong. So my answer is A. Okay, so pause and have a go, guys. So this question is making copper in the reaction between magnesium, copper sulfate solution. Magnesium atoms become magnesium ions, Mg2+, and copper ions, Cu2+, become copper atoms. Write a balanced ionic equation for this reaction. Okay, so again, I don't have enough information to start doing that complex stuff that we liked. So what have I got? I've got magnesium atoms become magnesium ions. Okay, so it's going to look something like this. Mg making Mg2+. And then it says copper ions become copper atoms, which is Cu2+ becoming Cu. Does that balance? Does that make sense? Yes, of course it does. That's a displacement reaction, isn't it? Huh. Okay, last one then, guys. This is taken from the white question book, in case you're interested. Have a go. Okay, so I'm going to use that 5-point criteria just to make sure I'm online. Okay, so I've checked it's balanced. Yep. I've identified the aqueous solutions. So that's this one and this one. I'm going to separate out the ions. So I've got that and that. How do I know that tin is Sn2+? Well, I should know that sulfate is 2-, and therefore to make that balanced, tin would have to be 2+. This one here again, Zn is 2+ for the same reasons. Okay, next then I'm going to cancel out the spectators. Lovely. What's left? I've got my tin and I've got my zinc ions. I'm not going to forget the solids that I left in the original equation. So I'm going to have Zn solid plus tin aqueous, making zinc aqueous plus tin. And that's it, guys. Right, that's the end of this lesson. I hope it's been helpful. Practice makes perfect. I'll see you next time.